if you observe very carefully, you get to realize that there is no any problem regarding comparing the rate of diffusion of hydrogen gas to that of oxygen gas at the same conditions of temperature and pressure. So just take note that given a question like this, take note of the what? Of the relative atomic masses of the atoms present in the gases. Then calculate their relative molecular masses as we have done here. Then use either this formula or this formula. You still get the same answer. Or should we use this one to see if we get the same thing? Or you've already understood that anyone you use, you get the same answer. Anyone used, you still get the same thing. Is that okay? So, substitute in the values here, then divide. If divisible, then whatever possible, take your final answer, then cross multiply, and then you get the rate of diffusion. Remember we said this very one here says that the rate of diffusion of hydrogen gas is what? 4 times the rate of diffusion of what? Who is reading? Who is reading the next question for us? Why not read for us? A gas X diffused, okay, through a porous partition of what? 3 mil per second. Under the same condition, hydrogen diffused at the rate of what? 15 mil per second. 15. Okay. What is the relative what? What is the relative molecular mass of what? Gas X, right? Okay. Is there any additional information we need? No, right? That's all? Okay. Now, taking a look at this question, we have some values given, some quantities given in the question. This 3 mil per second, from the unit of measurement, mil per second means what? cm cubed per second, which stand for what? Good, rate. Now, we have gas X. So the rate of diffusion of X gas over rate of diffusion of hydrogen gas is equals to the square root of the relative molecular mass of hydrogen gas, square root of the relative molecular mass of hydrogen gas divided by what? Square root of relative molecular mass of what?
X.
Of X. Now, the rate of diffusion of X is given to us as what? 3 mil per second. So you now write 3 over rate of diffusion of hydrogen is what? 15, which is equals to root. Do we know this? Yes. Which is what? 2 over. Do we know this? No, we don't. So it has to be mx. Okay? So what do we do next? We cross what? So just like that, we have to simplify, isn't it? 3 here, 1, 3 here. Isn't it? We have 1 over what? 5 is equals to, in this case, we have what? Root 2 over what? Over root mx. So cross multiplying, root mx is now going to be 5 times root 2. Isn't it? So what do we do here? to find root 2, isn't it? So what is our root 2 here? But if you take a look, can we apply sort form? As this goes in, this becomes 5 times 5, isn't it? Times 2, right? Which is root 25 times 2, which we are going back to this one, isn't it? So automatically from here, don't even waste time. What is root 2? So 5 times what? Root 2 is what? What is root 2? 1.4142. Okay, multiply by 5. What do we have? 7.0711. Isn't it? Okay. Now, we can't leave this like this. We need to remove this sign. So what does that mean? We square what? So square, or take the square of both sides. Is that okay? So in this case, we have root mx, square this side by putting what? Is that okay? Which is equals to 7.0711 squared. So this will cancel this one. So we are left with mx is now equals to, what is the square of this guy? 50 dot 7.0711 squared. 50 dots. So in that case, do we get it now? Any confusion? So what do we have in our notes? Is it correlating? No. That is exactly what is there. Though the steps in the notes there have not been, itemized. So at least this one will help you to comprehend what is there. I believe that is why Elizabeth is saying that we should solve. Right? Yes. So any confusion? Check. If there's any confusion, then we fix it. So can we proceed to the next example? Or you understood fully? You understood fully? Okay. Do we need to solve it? Elizabeth, you should solve the last one, Paul. Okay. So, I want somebody to come and solve this for us. Between the four of you. Who can try? When we are going to solve, you can do that, right? The question says, if 100 ml of methane, and what is that our methane? CH4. One of the most important components in natural gas. Diffused through a porous spot in 1.0 seconds. How long will it take the same volume of sulfur oxide to diffuse through the same pot under the same conditions? That is, we didn't do example 3. Okay, if 100 ml of oxygen diffuse in 4 seconds and 50 ml of gas Y diffuse in 3 seconds, calculate molecular mass of Y. So what I expected to do there, have you been given rates? Have you been given rates of diffusion? Yes. You have not? Have we? You look for it. Isn't it? So divide volume by time. Isn't it? Isn't it? Yes. If you do that, do it now. Example 3. Solve for the rate. Divide what we have as volume by the time given. After you have done that, what next? Did you get the rate of diffusion of oxygen? Yes. What of that of Y? That of gas Y. Did you see that? Good. If you do that, you have the rates. Then use the rates formula. Then you calculate to verify that what we are having there is what? 69. So confirm.